Yay! I have the keys to unlock Pocket Ronnie. Okay, we're going to be doing planes and sets today, not airplanes. From lesson 1, you learned the smallest unit in geometry is a point. And a point has no dimensions. There's no length or no width in a point. Then the next thing that we dealt with is a line. A line can go in forever in both directions, but a line can also just be part of a line, like a line segment. And a line is considered to have one dimension, length. The next thing that you're going to come across in geometry is a plane. Okay, a plane is defined as something that's having its two dimensions. So it's two dimensions, it has length and width. So this picture right here is a plane. It has length and a width. A plane can go on forever in both directions. Like this can go on forever in this direction, and this side of the plane can go on forever in this direction. This dry erase board that I'm writing on is a plane. It has length and width. The walls in your house are a plane. They have length and width. They are two dimensions. So a plane, your notebook paper that you write on is a plane. It has length and a width. Your Matthew C. workbook page is a plane. It's two dimensions. It has a length and a width. Okay, the next definition that you need to learn is coplanar. Just like collinear was two or more points on a line, coplanar is, I'm making sure I spell coplanar right. Coplanar is when two or more lines exist in a plane. So like if I had a line here and a line here in this plane, those lines are coplanar. Those lines exist together on that plane. Let's say you had let's see if I can draw this. You had a parallelogram right here, and then you had one that went into the paper, like it's going to go down, and then it comes on the other side, it comes out like here. Imagine that this is one piece of paper inside another piece of paper. Okay, this would be like plane X. That piece of paper is plane X, and then this one would be plane Y. There, that looks better like that. So those are two different planes intersecting. And when two planes intersect, where they intersect right there, they create a line. We're going to talk more about that in the next lesson. Maybe that's if not, where two planes intersect, it creates a line. If you think about the two walls in your house, where two walls come together in your house, where it creates a corner, it creates a line. Now I can draw that one. This is two walls in your house. There's one wall. So here's wall A and here's wall B, and where they come together right there in the corner, they create a corner, it creates a line. So where two planes intersect, it creates a line, like the corner. Another definition that you need to know is when you're talking about two dimensions, that is called plane geometry. Not P-L-A-I-N like it's boring, but plane because you're dealing with planes. You're dealing with two dimensions, plane geometry. When you start getting into three-dimensional geometry, when you're dealing with a sphere, a cube, a pyramid, those are all 3D objects, it's called solid geometry. 3D objects in geometry are called solids, and that's solid geometry. Okay, the focus of lesson 2 is I really want to focus on these definitions right here. So the first one I'm going to start with is set. The symbol for set is kind of looks like brackets, but it's not. It's this symbol here, set. So like let's say I want to say the set of even numbers. And I do that, the set of even numbers, 2, 4, 6, 8, and I could go on. So these symbols mean I have a set of something, and whatever is in there, that is my set. So when you're talking about an empty or null set, when there's an empty set, meaning there's nothing there, there's no answer. Null also means nothing. The symbol for that is like 0 with your slash through it, empty or null set. Subset is a sideways looking U. So let's say I have a set of numbers of 2, 4, 6, 8, 10. Well, within that, a subset of this, I can say it like this. 4, 6, 8 is a subset of 2, 4, 6, 8, 10. Subset means that it is contained in. So when you're a subset, this 4, 6, 8 is contained in this set. It is contained in it. So let's go back up here to this definition. Union. The symbol for union, you can remember that because it looks like a U. U for union. Union means two or more things that are combined together. The key word that I would remember for this is combined. Union means you are combining together. One way you can think of that is two people getting married. When you are getting married, you are combining together in union of marriage. So union is combining together, you're adding together. So intersection is the opposite of union. If you can remember U for union, then intersection is the opposite of that. The other one that looks like this is intersection. Intersection, when two things intersect, they meet or overlap. So like when two roads intersect, they meet together. Or sometimes some of the intersections are overlapping each other. So just quickly, U for union, combining, adding together. The opposite of that is intersection, two or more things meet or overlap. This symbol means a set of numbers, a set of something. This means there's nothing there, empty or null set. The sideways U means subset. So let's just look at this example down here. Okay, if I want the union, remember U for union, the union of 1, 2, and 3, the set of 1, 2, and 3, and the set of 4, 5, and 6. If I am just taking those two things and combining them together, then I have the set of all the numbers. 1, 2, 3, 4, 5, 6. Because union means combined together. I just take this and combine them together. This is intersection. So I look at this set, 1, 2, 3, 3, 4, 5. Intersection means meet or overlap. Where do these two sets overlap? Well, they both have a 3 in common. So where they overlap is they both have a 3. So that is their intersection. These are just two examples to look at with those definitions using numbers. Well, now we're going to work some problems with these definitions with line segments and lines and rays. So if you look at 2B, all of these problems are true or false. In my opinion, you need to work them out and determine your answer. Then you'll know if it's true or false. Okay? I always recommend using two different colors to redraw this to help you with your solutions. This reads, first off you have to know the symbol, U for union. So this reads the union of line segment QR and line segment ST. We want to know what is the answer when you combine, because union means combine together. When you combine line segment QR and line segment ST, do you get an empty or null set or do you get something else? My recommendation, look at your figure. So we're going off this figure. You always look at your given, okay? The given says that line QT and line VW are straight lines and they intersect at S. Always read your given. My recommendation is to take what they're asking out of the picture. Okay, we're looking at line segment QR. Here's line segment QR. So I'm going to redraw line segment QR. And then I'm going to use a different color pen to draw ST. Here's ST. Now let's just pretend this red dry erase marker represents QR and this blue one represents ST. I want the union of those. Can I combine those together? Yes, you can, because all you're basically doing is taking these two dry erase markers and putting them together. They're basically two line segments end to end. So you can combine them together because that's what union means, is just combine them together. So when you redraw them out of the picture, you have line segment QR, and then you basically have line segment ST, basically right next to each other, end to end. So your answer is not empty or null set. This answer is false. Basically your answer would just be the two line segments combined together. So it's pretty difficult to write that because basically you'd have to write it in words. It's just basically QR and ST side by side, if you want to write it that way. They don't ask you to write what the actual answer is. They just want you to know is it true or false. I just want you to know that you can take two line segments and put them together. It's just basically two line segments side by side. So false was your answer, and this is why. Look at 15. First off, you need to know what this symbol means. This symbol means intersection. It's not U for union, so it means it's the other one, intersection. So this reads, you want the intersection of ray SQ and ray SV. Okay, I'm not even going to worry about what this is yet. I'm just going to draw these out and then see if my answer matches that. If my answer matches that, it's true. If my answer does not match that, it's false. Remember, intersection means where they meet or overlap. So the first thing I want to do is draw ray SQ. Remember, this is a ray, so rays have an endpoint. Okay, here's ray. So ray SQ starts with point S, and then it goes toward Q. Okay, so here's point S. So there's my point S, and then my ray goes toward Q. So there is ray SQ. And I'm going to enter, I want to know is there an intersection SV? Here's my point S, and my ray SV goes toward V. So I'm going to draw that with a different color. So there is my point S, and then it goes up toward V. So in your picture, for intersection, when you draw two different colors, you look at where do the colors overlap, or where do they meet. The only places that my colors overlap is point S. I have a red on the point S and then also a black. So right here is my only place that my colors overlap each other. So, and since intersection is where they meet or overlap, then point S is where these two rays meet or overlap. So then you can see my answer is not line QV, so this is false. The real answer would be point S. Where they meet or overlap is at point S. Okay, let's look at 16. We wanted to know the union. U for union. Union means combine or add together, that you are combining. So we are combining, we want the union of ray ST and ray RT. So my recommendation is to draw this ray first. Remember, we're starting at point S. This means this letter tells us our end point. So we are starting at point S and then we're going towards T. So I'm just going to redraw it out of the picture. There's S, and then if I go towards T, I'm going that direction. There's my ray ST. Now I'm going to switch colors to draw my second one. So I want ray RT. So here's R. That's my endpoint, and I'm going towards T. So here's R was to the left of S. So I draw it there, and then I go towards T. But I want the union. I'm not really concerned about where they overlap. I'm combining the two things together. I'm combining ray ST and ray RT. I'm combining those together. When I combine those together, what did I get? I have ray, can we call this ray RT? Yes, we can. You would call it ray RT because this is the end point, and then it goes towards T. This also could be called ray RS. So ray RT, that is true. This is a true statement. Also, that ray could also be called ray RS, as we learned in lesson 1. The endpoint is what is the main thing here. It has to be the endpoint of R, or R, but this ray could either be called ray RS or ray RT. So either one of these answers are acceptable for this. So 16 was a true statement. Alright, let's look at 17. First off, you have to know, what does this symbol mean? This symbol means subset. It means one thing is contained inside the other. So we want to know, is ray SV contained within line WV? So first off, I'm just going to draw line WV from in my picture. Line WV looks like this. Okay, here's V, here's W. Okay, now I'm going to switch colors and just draw ray SV. S starts here, there's S, and then it goes toward V. So is ray SV contained within line WV? Yes, it is, because S starts here, and that ray would be within this whole line. So that is a true statement. Okay, now let's look at number 18. Remember, you need to know what these symbols mean. This is subset. So we're asking, is set QRS, meaning is points, R points QRS, a subset of line segment RT? So I would draw line segment RT, or even you just look at it. Here's line segment RT. Okay, RT goes from right here to right there. There's T, there's R. You can see point S is in there and point R is in there, but is point Q in RT? No. And they want, is QRS a subset of RT? Q, R, and S have to all be in RT. Q is not, so therefore that is false. Because only points R, S, and T are in line segment RT. Okay, now let's go up to this figure up here. We're on page 2D. We're going to be doing 16 and 17, and we're looking at this figure. In your book, all of these lines are in a plane. And the given says all three lines lie in plane X, and they intersect at point L. Okay, that is point L. It's hard to read my handwriting. And all of these lines are straight lines. They look squiggly. My arm is a little shaky today, but we're going to pretend like all of these lines are straight, that I am a perfect drawer, and that mine are all straight lines. So, number 16. Again, you need to know what this symbol means. U for union. Union means combining together. We are combining together, where they add together. We want to add together, combine together line segment EL and line segment LH and see what we get. This is not true false. You're going to give the answer. So my recommendation is to draw it. Here's EL. So if I was to just take this out to the side and redraw it the way it is, line segment EL. There's EL, kind of the same way that's here, angled like this. So there's line segment EL. And I want to combine that with LH. Here's LH. So then if I combine that with LH, LH. This is not intersection where they meet or overlap, it's just combining together. So I drew line segment EL and then I drew line segment LH, and when I combine those together, what do I get? I get line segment EH. So this is equal to line segment EH. Can you name it a different name? Sure. You could also call it line segment no, you wouldn't call it line segment EL. It's got to be all the way from one endpoint to the other endpoint. So there's really only one good answer. Line segment EH, all the way from this endpoint all the way to H. So line segment EH is what you get when you combine those together. Okay, now let's look at 17. Again, we're doing union. Union means combining together. Combine is the key word. We want to combine together ray EL and ray LH and then give them the answer of what do we get. So, from your picture, draw ray EL. Remember, the one on the left is your endpoint. E is your endpoint. There's my endpoint E going towards L. So here's E, and then I'm going towards L. So there's E, and then here's L. Then if I draw a ray LH, well, I'm just going to use a different color. So there's L, then redraw LH, here's H. If I combine those two rays together, if I add them together, join them together, what do I get? I get ray EH. So this could be called ray EH. Remember that ray symbol is very important up there. With this one, you could call this ray EH. You could also call this ray EL, because if you start at E, go through L, and just keep on going. That's the only names. E has to be the endpoint, so it's either going to be called EL or EH. So those two are either two acceptable answers for number 17. Alright, we're on page 3D, even though this is part of lesson 2 and I'm doing some problems on lesson 3. This is just to help you out because these problems progress. You have this figure right here, and in the given it says plane X and Y intersect at line CD. Two planes intersect to make a line. So number 15, we have union of ray CE and ray CG. So my best recommendation is to draw it. Draw ray CE. Here's ray CE. C is right there. It goes up towards E. There's E. And I'm combining it with ray CG. Here's C, and it goes down. There's C, and it goes down towards G. So when you combine those two things together, what have you made? You have made line GE. You could also call it line CE or line CG. We have made line EG. You could also call it GE. We have made a line. When you combine those two rays together, you make a line. Number 16, intersection. Intersection means meet or overlap. We want the intersection of ray CE and ray CG. So that's what we just drew. So if we drew CE, here's C, and then it goes up towards E. There's E, C. Now use a different color. It's always important to do different colors for intersection. CG, there's C, and there's G. Where do our colors meet or overlap? Right there at point C. So when you draw those two rays together, they intersect at point C. Number 17, in which planes do A, B, H, and J lie? If you go back to your picture, A, B, H, and J, they all lie in plane X. Those are all in plane X. Number 18, how many points are there in a plane? Well, if there's an infinite number of points on a line, and then there are an infinite number of lines in a plane, then it stands to reason that there are an infinite number of points in a plane. Look at number 19. We want intersection. The intersection of ray DC and ray CD. Intersections, it's important to do two different colors. So DC. In our picture, here's D, and we go towards C. There's that. Now we want CD, which means we start with C. There's C, and we go towards D. Where do our two colors overlap? At this line segment right there. The blue and the black overlap at line segment CD. So where the two colors overlap is line segment CD. So when you combine, when you intersect ray DC and ray CD, you make up line segment CD. Number 20, we're dealing with union. The union of ray DC and ray CD, we're combining together, union. So ray DC, here was, start with D, go towards C, there's C, D. Now if I do ray CD, remember we're doing union, not overlapping of intersection. There's point C, and I go towards D. So when we combine those two together, what have we created? We've created a line. Because we combine those two together, so we have created the line CD. These symbols above are very important.